Well, this is Reassessment number 7, standard work energy. Alright, so for this reassessment I did two problems. For the first problem, it asks us what is the magnitude of the force of which the two people pushed. Well, so we have work done equals the change in kinetic energy, right here. And we also have work equals force times delta R. So it says it starts from rest, so the initial kinetic energy would be equal to 0, and we have our kinetic energy equation, 1/2 mv squared. So we could do work equals kf minus ki, where ki equals 0, so that cancels out, and we're left with work equals 1/2 mv squared. We could take force times delta R, because we are looking for the force, plug it in for our W, get F alone, so we're solving for force. We're given delta R, which is 8 meters, V, the velocity, which is 0.4 meters per second, and the mass, 12 kilograms. Plug everything in, we get a force of 0.12 newtons, and that's the force they pushed on each other. Alright, for the second question, it's all about the work done by a pitcher throwing a ball, and then how many balls would he have to throw to burn a certain amount of energy. So for part A, sorry, it asked us the work done by the pitcher. Okay, so we could start by having our work energy equation, W equals delta K, or W equals KF minus KI. K would equal 1/2 mv squared. Ki would be equal to 0 because it starts from the rest. You haven't thrown it yet. Initial. So we're left with the work equals 1/2 mv squared. We're given the mass, 0.153 kilograms, and the velocity, 40.2 meters per second. So then we plug it into our work equation that we came up with, and we're left with 123.68 joules. Alright, so the next part of the problem, it tells us the amount of total energy that is turned into kinetic energy. That was 20%. And it tells us how many calories he wants to burn by throwing these fastballs. So we have the 20%, and we have the amount of calories, which we have to convert into the joules, the total amount of energy burned, because we need joules for energy. Sorry, unit of joules. So we multiply that by 0.2, the 20%, to figure out how much is actually turned into work. So we get 1,272,544 joules. We then take that by our previous part A total amount of work done, and we get the amount of, kinetic energy divided by the amount of kinetic energy thrown by one fastball, and we would be left with 10,293 fastballs you would have to throw in order to burn off that amount of energy right here. Alright, that is it. Thank you for your time.